Okay, so I've got the blood type Punnet Square. Wanted to go back over that again with you guys, just review that real quickly. So the ABO blood group refers to, your blood type may be something like type A positive or type AB negative, right? So it's the ABO portion, so either type A, type B, type AB, or type O blood, that's controlled by one set of alleles. And then the positive or negative, so if you're O negative, the negative part is controlled by a different set of alleles. Okay? And so two different traits, both affecting your blood type. But the ABO blood group is controlled by these three alleles here. So you can have a dominant allele that produces the A protein, a dominant allele that produces the B protein, or the recessive allele that does not produce a protein at all. And if you get two recessive alleles, you end up with type O blood. Okay, so we did this part in class, but just want to go back over it again real quick. So your possible genotypes, remember you get two alleles for each trait. So for type A blood, you could get two dominant alleles with the A protein, or you could get one dominant allele with the A protein and one recessive allele. Same thing for type B blood. Okay, for type AB, you have to get the dominant allele for A and the dominant allele for B. And for type O, you have to get two recessive alleles. For the Rh factor, you have to, we're using a different set of alleles. We're using the letters D for this. So Rh positive can be heterozygous, big D, little d, or homozygous, big D, big D. Rh negative person has to have little d, little d. Okay, so we had to go through and list out the genotypes for Mark and Molly. Mark is B positive, so he could have homozygous dominant for both traits. Could be heterozygous for both traits. Could be homozygous dominant for the ABO group and heterozygous for the rhesus, or it could be heterozygous for that B protein and homozygous for the rhesus protein. Molly, she is A positive, so she could be homozygous dominant for the A protein and homozygous dominant for the rhesus. She could be heterozygous for both traits. She could be homozygous for the type A and heterozygous for the rhesus, or she could be heterozygous for the type A and homozygous for the rhesus. So we got four different possibilities for each of the parents. Now we have to go through and use the kids. Jill is AB negative, Andy is O positive. And we can use the kids to figure out which genotype the parents actually are. So to get AB, you have to have the dominant I with the A type and the dominant I with the B type. But to get that negative, you have to have two little d's. To get type O blood, you have to have the two little i's. You could have big D, or you could have big D, little d for that positive. Okay? So now remember, Jill, she's a product of a sperm and an egg. Sperm and eggs only carry one allele each. So for her to get two recessive alleles, she had to get one from the sperm. She had to get one from the egg. So we can go back to the parents and cross out anything that does not have a little d. For Andy to get type O, he has to get two little i's. Same thing, he has to get one from each parent. So we can go back up here and cross out anything that does not have a little I. And so that's how we eliminate the genotypes for the parent to select the one that's correct. So Mark's correct genotype was big I with a B, little I, big D, little d. Molly was big I with the A, little I, big D, little d. Okay, suppose they want to have a third child. Determine the phenotype possibilities and ratios for that third child. Start by listing the possible gametes of Mark and Molly. So remember what we do here. I use this little arrow system to help kind of understand. So I'm taking the first allele for the first trait, combining it with the first allele for the second trait. You get one allele for each trait on each gamete, right? I can also do big I with a little d. And I can do little I with a big D, little I with a little d. Molly said this was her genotype. So I can have big I with the A, big D, big I with A, little d, little I, big D, little I, little d. So those are the gametes. Then we're going to put those on our Punnet square. So mark on the top, big I with a B, big D, big I with a B, little d, little I, big D, little I, little d. Molly down the side. Okay, and then in this first square, we're going to combine this sperm with this egg. Since A comes first in the alphabet, we're going to list the A allele first. So big I with the A, big I with the B, two big D's. Big I with the A, big I with the B. We learned previously that if you've got both the dominant allele and the recessive allele, you put the dominant allele first. Okay, and we also learned previously that since we started with the I's and followed with the D's, we're going to keep that same pattern throughout as well. Okay, so just finish up our Punnet square here. Big I with the A, big I with the B, big D, little d, big I with the A, big I with the B, two little d's on this one. Big I with the A, little I, big D, little d, big I with the A, little I, little d, little d. Big I with the B, little I, two big D's, big I with the B, little I, big D, little d, two little I's, big D, two little I's, big D, little d, big I with the B, little I, big D, little d, big I with the B, little I, two little d's, two little I's, big D, little d, and last, two little I's, two little d's. Okay, so now we got to go into each of these squares and write the blood type. So I've got the A protein and the B protein here, so that's type AB. I've got a dominant allele present for the rhesus, so I'm going to put a plus sign, so that's AB positive. AB positive. This one I don't have the B protein anymore, so it's just type A. I've got a dominant allele for the rhesus, so A positive. There's another A positive. AB positive. AB. Now I've got two little d's. That's the recessive trait for rhesus, which means I won't produce the protein. So AB negative. A positive. A negative. I've got the two little d's there. B positive. B positive. Now I've got two little i's. Remember, that's the type O. That's the absence of A or B protein. We've got a dominant allele for rhesus, so that's A positive. I'm sorry, that's positive, so O positive is the blood type. Another O positive, B positive, two little d's, so that's B negative, two little i's, so that's O positive. And last one here, I've got type O, and I've got the negative, so O negative, okay? So let me just write these down at the bottom. We've got all 8 blood types, AB positive, and there are 3 of those. I've got A positive, and there are 3 of those. I've got AB negative, and there's only 1 of those. I've got A negative, and there's only 1 of those. I've got B positive, 3 of those. O positive, 3 of those. B negative, only 1 of those. and O negative. Only one of those. So that's my phenotype ratio. 3311, 3311. Okay, and the last question here, what is the probability of the third child having the O negative phenotype? Well, there's only one square that has the O negative. There are 16 squares in the Punnet square, so 1/16th probability. That's it.